So if someone asks you, why does a box stay on the table? Why does it not fall through? What do you say? You think, oh, it'd be silly to ask the question though, because we have the table. And that is what tables for. And a person is hitting the wall. He would feel hurt, wouldn't he? Of course, because he just hit the hard wall. And it's because of the wall. But physicians, they do have a different answer. They blame for the normal contact force. So what normal contact force is, and how can we demonstrate it and calculate it? It is our topic for today. But before we go through all the problem with normal contact force, we better do some revision about forces and Newton's first law, which are really relevant to normal contact force. First, how to draw forces acting on an object. Remember, forces are vector quantity. It means it has magnitude and direction. It has magnitude and direction. Let's draw a vector. The origin of the vector is where the force acting on. It shows where the force acting on. And the arrow shows the direction of the force. In this case, it goes from left to right, but it can be any angles, vertical, horizontal, at any angles. In this case, this one shows us that the force is from left to right. And the length of the vector presents the magnitude of the force. I would say it is 5 Newton. So if you have another force with the value of 10 Newton acting in the same direction, you draw it like that. Same direction, and the length is double. I'll say 10 Newton. However, you don't need to worry too much about the length of the vectors and the magnitude of the force when you draw it on the diagrams, but you do need to care about the direction. Another thing you always keep in mind, this helps us to calculate the forces, is Newton's first law. It states that if the object remains at rest, and then the next force is 0. Now we can do some practice about drawing vectors and calculate the magnitude of the vector. Okay. If we have a mass or a box, stay at rest on a table. Okay. Use the rules above to draw gravity force acting on the objects. We know gravity force is acting downward, so the vector should go downward. And it is acting on the object, so it should start somewhere inside the box here. And it's going downward. And the mass is 0.1 kg. This means it has the weight around 1 Newton. We are living on planet Earth anyway, so it could be different if you go to the Mars. Then now the object is pushed forward from left to right. Our object is now pushed forward from left to right. It's our table. It's pushing from left to right, so the vector P is kind of this direction from left to right, and it is acting on the object. So you should start somewhere here in the object. And go here, and it's set 5 Newton. Now that's your exercise to use the rules to draw the forces acting upward and pull it backward. Okay, that is the exercise. If we have another forces involved, we are still able to draw all of them. And now look at this one. This is our object on the table again. It is pushed forward. Is it pushing forward with a force of 5 Newton? And it has friction. So friction force, as we learned before, it should go this way. I make it too long. I should be able to do it a bit shorter, but anyway, I'd already written down 1 Newton, so you know this 1 Newton. Now I have a gravity force. Gravity force acting downward. Gravity force acting downward. And it is 1 Newton because our object is 0.1 kg. So you know how to draw vectors or forces. You remember about Newton's first law. Then now we're back to our main topic for today, normal contact force. What is it? The normal contact force, it is a force exerted on an object. It exerted on an object that is in contact with another stable object. When I say stable, it means it doesn't move around and it's hard. It is everywhere. Normal contact force, it is everywhere. We just don't notice it or they can ignore it. So normal in this definition doesn't have anything to do with abnormal or extraordinary. It just means perpendicular. And the normal contact force is perpendicular to the surface of the contact. So normal means perpendicular and perpendicular to the surface of the contact. So if we have the contacting surface here, then the normal contact force has to be perpendicular. Contact in this definition means the force is only present if the objects are in contact. It's only present if the objects are in contact. And sometimes the normal contact force is referred as normal forces or reaction forces. Now we look at a couple of examples just to demonstrate the normal contact force on a diagram. We have an object with mass 2 kg and it stays at rest on a table. Now draw and calculate all forces acting on the object. So it is our object. Stay at rest on the table. And now it says table, it is horizontal with hard surface. The object has mass and it has weight. And we know it's acting downward and it's 20 Newton. Right here we only see one force acting downward. It is gravity force. But Newton's first law said that if the object remains at rest, the net force had to be zero. If the object remains at rest, the force has to be zero. So it must have another force acting upward. It must have another force acting upward. And it is a normal contact force. It's acting upward and it is perpendicular to the contacting surface. Perpendicular to contacting surface and acting upward. And the net force is zero. It means R take away W will be zero. It will give us R equal 20 newtons. So in this case, the normal contact force is 20 newton equal to the gravity force and in the opposite direction. Right, we look at example 2. What does it say? An object with mass